Mapr Technologies. And the topic of today's speech is called Thinking Big with Hadoop. So I thought, what's the best slide I can start with? How can I generate some enthusiasm for Hadoop? First of all, who's heard of Hadoop? That's pretty good. Well, here's my attempt to get your interest. I pulled this afternoon from Indeed.com. This shows the job trends from Indeed for the top technologies that they list. They listed MongoDB, Android, mobile, whatever mobile means, HTML5, social media, and Hadoop. The orange bar, I guess on this screen, is kind of dark red. The one up and to the top, the exponential growth, is Hadoop. Now are you interested in what I have to say? So, a lot of demand, a lot of activity around Hadoop, and it's really kind of eye-popping. The previous speaker talked a little bit about big data. This just shows big data across industries. I think the takeaway here is this is not a Web 2.0 phenomena. This is cutting across industries. We're seeing Hadoop deployments in brick and mortar companies, retailers, organizations that you would characterize as late adopters are really jumping on Hadoop. Now they're at different stages. Some are still in the experimental phase, but some are well underway in terms of deployments. And what's driving this is this just exploding data. And if you sat through any presentations, I call this the obligatory big data slide. Right? It shows, some small sphere growing to be massive and talk of zettabytes, etc. The key point here, though, is not the size of the data, and not even the growth. It's just the rate of growth is growing faster than Moore's law. So however you're processing data today, whatever cluster you're using, it's going to get bigger because the speed and deployment of Moore's law can't keep up with the data growth. And so what that's really forced is a paradigm shift. So the old model of you have data over here and some network storage, and you have compute over here, and you're going to drag the data over and do compute, doesn't work anymore. It's taking longer to pull the data across than to do the analysis. And the key part of Hadoop is you're doing data and compute together. So you're doing compute on the data and sending the results over the network. And you're also doing it in parallel and doing it with cheap commodity hardware, etc. But it's a paradigm shift. It's breaking the old architectures of the past. And in a sense, it's a paradigm shift. It's a pendulum coming back. We used to have data and compute together in the mainframes, but it cost another $5 million to buy another mainframe when your data filled up. So, EMC and other companies kind of spread this across and said, look, you can save money by separating out the SAN network from the compute, and you've got this modular design. And that worked well for a few decades for us, but now we're in this massive paradigm shift. And this started with Google. So what MapReduce is you spread the data across parallel clusters. You've got a map to know where the information is, and it's replicated. So the instruction set comes in, and it takes those, separates those out, runs them independently. The reduce set brings all the results back, and it assembles it for you. So from a developer standpoint, you don't have to understand where the data is. You don't have to think in a parallel way. That framework does it for you. That's what MapReduce is. That's kind of the heart of this. And the poster child for the power of this, in my mind, is Google. So we take kind of Google's dominance for granted, right? When they came out in beta in 1998, they were the 19th search engine on the market. Search was done, right? Yahoo was $1 billion. Alta Vista had TechCred, you had Excite, you had InfoSeek, you had LookSmart. I mean, they were on and on and on. They were the 19th search engine. And within 2 years, they were the dominant player. An incredible change in the market dynamics, and it was because they had this back-end infrastructure that could index more data, do it much faster, do it much cheaply than anyone else. And we didn't know what it was until 2003 when they published a white paper talking about this MapReduce framework. And there was an engineer at Yahoo called Doug Cutting that read the paper, said, I'm going to try this for my Nutch search project, and I'm going to see how this works. And so he implemented in Java, and that became the open source project that we call Hadoop. Now, there are a few commercial distributions on Hadoop. Just a little background so you understand where I'm coming from. Mapr, our CTO, came from Google, and we actually looked at that architecture and said, well, that implementation done in Java on top was appropriate for certain use cases, but if you really want to take advantage of the broad use cases that are possible, that infrastructure has to change. You have to rewrite that, make it more enterprise grade, have that be kind of more real time. There's a lot of details there, but that's just kind of the background as we get into Hadoop. So I want to get into some of the drivers, right? So why is this excitement? Why is that curve exponential in terms of the demand? Well, one is the cost of storage is dramatically different with Hadoop. So it's 1/200th to 1/20th the cost on a per terabyte basis. And here's a comparison across SAN storage, across NAS. And basically with Hadoop, you're using local storage. You're using local disk drives attached to a node. So, $100 a terabyte. And that disk density continues to increase as we're seeing continued innovation. So there's a big cost driver there in terms of, or cost advantage to store the data in Hadoop and then do analysis on it, because if you're storing all this data, 7 years of transactional information, you can do analysis directly on it and just extract the information you need instead of trying to pull up back 7 years of data to throw into some database or some transactional system. But there are other drivers that are even more important. So one, we talked a little bit about it's more efficient to do data on compute, but two, you don't know the questions you need to ask beforehand. And that's a real hidden obstacle with data warehouses and analytic systems. Right? You have to set up the schema ahead of time. You have to go through an ETL process to process that information. And I was talking to a director of IT for a large insurance company. He said, I'm batting about 50%. I said, well, what do you mean? He goes, well, half the time the analysts kind of aren't really sure what they're going to ask ahead of time, so we kind of guess. And then by the time I deliver that analytic warehouse, they need to change it. So it's kind of back to the beginning process. And this is not a process of hours, days. This is kind of weeks, not months. He says, or they know exactly what they want, and they still want to ask those questions, but now things have changed, so now they have to ask new questions, so I'm back to address that system. So a big advantage with Hadoop, you just take the data, dump it there, and you've got all this flexibility to do analysis, on top of that. And you're not limited by SQL. You can take unstructured data side by side with semi-structured or structured, so it's very, very flexible. The third bullet here was an insight that Google provided. And Google's really kind of pacing the industry here. They do white papers every few years on their technology. The latest was on Dremel. There's now an open source project called Apache Drill that's focused on delivering that. That one Mapr is very excited about. But they did an article that appeared in the IEEE, and it was called The Unreasonable Effectiveness of Data. And it was patterned after a paper called The Unreasonable Effectiveness of Mathematics. And it showed how simple algorithms can predict the physical world, E equals mc squared. Well, in this article, they said that behaviorists, economists kind of lament the fact that there's no simple algorithms that work to explain consumer behavior. And in this article, they show that simple algorithms that don't perform very well, once you throw a lot of data at it, they start to work really, really well. And they use the example of pixel completion, and I'm sure it's from Street View. They want to remove something in there, maybe it's a car with a logo, or maybe it's a guy in his lawn in underwear or something. They take them out, they want to fill in the background with this algorithm, and they said if there's a corpus of 100,000 pictures, it's kind of spotty. If you add 1 million photos, it's really good at filling in that background. And that's a great analogy, I think, to what we're trying to do with big data, where you're trying to explain human behavior, you're trying to fill in the gaps in terms of predicting the future, understand what's going on. And then the last point here is that you can combine unstructured and structured information. There's a lot of examples here. I think the simplest one in my mind to understand is you take tick data, stock market data, what's going on. You combine social media, like Twitter data, to represent sentiment, and all of a sudden you get to see patterns that are much more understandable and predictive than without any of social media data. Okay, so let's go through a couple of use cases. Disadvantage is ComScore. They're kind of the internet, the Nielsen of the internet. They go through and they predict and show what's going on in terms of uses. They're used quite extensively in the advertising agency to understand who's got traffic patterns, etc. Their focus was how do they ease development, how do they use standard tools against Hadoop, and how do they basically develop and meet these performance levers better. Rubicon is another example. Rubicon project, they're a real-time ad auction, so they match supply and demand. They handle about 50 billion auctions a day. So it's really kind of one of the engines behind these customized ads and retargeting ads that you see. Their issue was how to make things kind of lights out enterprise grade. Right? How to make sure that you've got a system that continues to run. And where Hadoop fits in is this kind of massive matching and clustering that goes on a near real-time basis. Ancestry.com. How many people have seen an ad or heard an ad on the radio from Ancestry? Yeah, they're the family matching one. Their latest, I think this is a sign that the whole market's moving to be data-driven. Here's an internet service in terms of family backgrounds. They do DNA matching. So you can spend $90, they'll send you a kit, you spit in a tube, they send it back to you, and they kind of do a DNA match and then reveal kind of elements of your family trait. So they're looking at performance, they're looking at ease of use, how do they drive the cost curve down. So a scalable engine that makes that possible is key. Now, last example here, and I'm going through these relatively quickly. If you do have any questions, raise your hand. The last example is disguised a little bit. They didn't want us to use their name, but they're a global credit card issuer. They started playing around with Hadoop less than a year ago. They rolled out within the first quarter a new service based on understanding kind of consumer behavior and clustering and recommendations. So think of kind of a Groupon app based on actual purchases. This has been very successful, and they've really expanded the use of Hadoop within their organization. And their issue was how do they equip the large number of developers that are experienced with using enterprise tools but are trying to get up to speed with this new technology called Hadoop. So a lot of SQL access into Hadoop via Hive, a lot of new productivity tools, and then how to kind of leverage some of the C++ and NFS interfaces that they have within their organization. All right, so that's kind of a quick overview of Hadoop. I wanted to spend a little bit of time into the distributions.
No, it's all.
So when we say Hadoop, and my guess is that not even someone in the front row can actually read the thing on this slide. So let me explain what it shows. This large bubble represents the Hadoop distribution. So when we say Hadoop, we're actually talking about a collection of packages and modules. So a Hadoop distribution contains things like Hive and Pig and Oozie and Scoop and Flume. And if you thought developers couldn't come up with crazy names, that's just the beginning. All right? And they all provide different capabilities. Some are for job scheduling and control, like Zookeeper. Some are for developing MapReduce jobs more productively, like Pig. Some are for SQL access, like Hive, that sits on top of it, generates SQL to go at kind of a MapReduce job. There's HBase, which has kind of a NoSQL capability. So all those are kind of bundled together. They're open source packages that allow you to make changes, etc. And that platform takes it, stores that data, and provides various data protection and capabilities. So one of the issues as you get into Hadoop is that there are some challenges that need expertise, that need people to understand what's going on. One of them is, how do you apply Hadoop, this open source project, these commercial distributions, to real enterprise grade environments, right? Whether it's mission critical, whether it's real-time applications, and it's basically moving Hadoop from a batch-oriented scratch pad into an enterprise environment. And as people are getting familiar with Hadoop, they kind of have questions like, well, I don't understand, what's the big deal? Isn't Hadoop used in 40,000 clusters or 40,000 nodes across some of these large organizations? Isn't it used by Facebook and LinkedIn, et cetera? Doesn't it have redundancy in a cluster? Isn't there replication there? What are some of the issues? So I thought I'd share some of them with you. Number one, there are single points of failure that need to be navigated. So having an engineer up to speed on what those are and helping navigate those is important. You've got user errors that can cause issues. So having training expertise, helping people with deployments, professional services as part of the ecosystem. There are exposures to data loss. So understanding how to do backup, understanding how to leverage snapshots, understanding business continuity is also kind of the leading edge for Hadoop. And really the key here is how to make Hadoop work for more organizations. So, regardless of what background you're coming from, as you look at this big data revolution, there are roles for developers, there are roles for developer tools, there are roles for QA, for training, how to leverage existing tools. So if you're an expert in Python, or if you really understand C, or there's even Sears was talking about doing an assembler to Pig conversion. So there's a chance to recycle a lot of backgrounds that you have and pointing them at this new frontier. And I'd also like to point out some key free resources. So, if you've understood half of what I said, or, were confused about what the heck Hive is or Pig, there are a number of free resources available on the web. I thought I'd highlight the ones I'm most familiar with. These are a free training and documentation site on Mapr, and consider it kind of just a taste, kind of a primer to get up to speed. So they're short attention span videos, average videos 3 to 4 minutes, but they're things like Hadoop 101. There are things like, and the location is academy.mapr.com. So there are things like writing a MapReduce application, why Hadoop, Hadoop 101, intro to a cluster. So there's content here from an administrator standpoint. How do you administer a cluster? What does it mean from an operations standpoint? There's information from a developer standpoint. There's things from data protection to understanding mirrors to how does snapshots work. So it's a chance to get at least familiar with what's going on, some of the concepts, and then dive deeper additionally. So, there's some architecture ones. We even have a few kind of oriented more from the business user to understand, well, what are some of the use cases? What are some of the impacts of Hadoop? And then, lastly, I wanted to point out there's a free Hadoop distribution. And this is free for unlimited use. We have quite a number of customers that have downloaded and deployed this. And there's some advantages here in terms of NFS support, in terms of performance, and in terms of a management control system, kind of a GUI. And I thought I'd give just a few seconds on those. The first is NFS. And what's interesting about Hadoop is that it's got a lot of power, but you have to understand the Hadoop distributed file system and the API. So the way to get data into a cluster is through that API, and the way to get data out is through an API. And one of the surprises that we hear from users is that, gee, I have to do everything through that API. And standard Linux commands are kind of hard to use. And there's a kind of simple hello world application for Hadoop, which shows a word count. So you can point it at like the works of Shakespeare, and then it'll come out and it'll tell you, the frequency of words. Well, to do a sort on that, you have to do another MapReduce job to do a sort. By exposing things like NFS, now standard tools can mount that cluster like storage. So you can access and manipulate the data. You can use a standard file browser and see the data. You can use standard Linux commands like sort. Instead of doing a MapReduce, you can tail a job. So it really kind of increases the productivity and the ease of use of interacting with Hadoop. The same thing is true with ODBC driver. And by supporting kind of NFS, you can support the real-time writing of data into a cluster. There's no need to close the file. And there's some details there in terms of how HDFS works, the fact that it's write once, you pen the data, you have to close the file to see it. If you've kind of innovated like Mapr has, then you can write that, support real-time applications, as well as support mission-critical ones with things like snapshots and mirrors. So that's one element. The second is how you can see the data. And there's a demo on our site, which I'll give them the time frame. I've got to make sure that Madhu's get time to talk. This control system allows you to see every single node in operation. That's what these little boxes are. And at the back of the room, those look like long bars, but each are separated. And you can see at a glance, what's the health of a node. We've got a demo on our site that shows running a Terrasort on a Google Compute Engine. So it's a virtualized environment. There's 1,000 nodes, and we do that in less than a minute, which is a world record we set last week with Google. And then lastly is performance, and there's a lot of differences there. And basically, it's taking advantage of the underlying performance attributes of individual servers, multiple NICs, etc. So there's a lot of performance characteristics that can be brought to bear on Hadoop and understanding deployment and sizing, etc. So this was my attempt in under 30 minutes to give you just a taste of what Hadoop is, a taste of big data. I highly encourage you to kind of take a step back. I think, if you're looking at what's next in your career, I think your timing couldn't be better. I mean, we're in the midst of a huge paradigm shift, and this is going to drive unbelievable changes within IT infrastructure, and those changes are going to drive, incredible opportunities. And just go back to the Indeed.com graph to show that any investment you make in understanding big data should have a pretty good payoff. So I think we have time for maybe one or two questions, and then, yes?
So I'm a Tableau analytics guy, for example, and I'm wondering, I haven't really used Hadoop, under the covers for Tableau or Cognos, BI type tools. So how hard would it be to add that, you know, if you want to expand your career, and let's just look at the Tableau, you know, Hadoop interface, how difficult would it be to wrap up on the Hadoop interface with Tableau, let's say, for example?
So the question was, how difficult is it to get up to speed from Tableau? I think the best way to explain that is it's kind of like a funnel that expands out. So I think it's pretty easy to make that first couple steps in terms of, you know, Hadoop can be a data source. I mean, Hadoop could be a large ETL platform, right, where you run a job to extract data to populate, you know, Tableau or look at a small cube, or et cetera. And then just expand from there and expand from there. I think where it gets real interesting when you start to do things that aren't possible today or aren't well used today. And I think making analysts more productive is a piece, but if you look at really where people are doing some interesting things with Hadoop, they're automated responses. And it's machine-generated data that's coming in, and there are these, either an auction engine in the case of Rubicon, a customer recommendation engine in the case of the credit card company, that are constantly moving and constantly kind of working. And instead of a data warehouse where you're analyzing and looking in the past and saying, what happened last quarter and what should I be doing, these engines are constantly making changes and impacting the business on kind of an hourly basis. Now there's room to do analysis to kind of go in and figure out, well, what are the tweaks that we should do, or what's this data look like before I run this 8-hour batch job to do a clustering. So it's part of the process, but it's just a piece. And I think that the real successful practitioner will have the understanding of the series of tools and then figure out, you know, which ones to apply. So I'd start with Tableau, and then I'd look at maybe the other end of the spectrum and say, what are some of these simple algorithms that people are running that, you know, are having a potential big impact.
And then if you, that's really good. And if you're in an enterprise, you walk into an enterprise like IBM or something, and they have all these, you know, legacy systems.
Yeah.
You know, like business objects or whatever.
Yeah.
So how do you get this Tableau? I'm thinking of the data warehouse. Yeah, you get it. So how do you interface Tableau with all those legacy systems with a minimal disruption, and then do all the things you just said?
That's why this NFS is pretty key, because basically you're using all the tools and ways to integrate, you know, you're just doing standards. And then I would look into clustering. I'd look into machine learning. There's a Mahout or Mahout. There's actually the two co-authors of the book can't agree on how to pronounce it, but that's a machine learning package on top of, or included in almost every distribution now. That's really interesting. Things like K nearest neighbor algorithm as a way to cluster is, I think, where a lot of these things are going. So that's the other end of the spectrum I look at.
Thank you very much.
Thank you.